Our job today is to find the difference of polynomials. So finding the difference of polynomials. Polynomial. Handwriting got bad, but my spelling has gotten better. So there's the good news. Here's what I always worry about. I worry about these two things. The first thing I worry about is that people see problems that look like this, and the first thing they do is assume that there's multiplication. So it's just the two of us talking right now. Has that ever happened to you? And if it has, join the club. It happens to everybody. So the first thing is be careful. Be careful. Think about this. So before I start moving on, I read the question. It said find the difference. But even if it hadn't, the first thing I would have done is I would have said, what's the operator? Operators are like addition, subtraction, multiplication, division, exponents, parentheses, etc. All the things that you know. So I see this symbol right here. It said it means it's a negative sign. It means subtract, doesn't it? So we're going to subtract. Remember, to subtract is to add the opposite. And what we're going to do here is we're going to distribute this negative sign. What I'm going to do, if you don't mind, is it helps me a ton, is I pretend this is a negative 1. And then I distribute that negative 1 in to get rid of the parentheses. So I'm going to do negative 1 times negative 4x squared. And then I'm going to do negative 1 times positive x. And if you're wondering, what am I going to do about the parentheses out here? Something similar. I'm going to do something similar. I'm going to pretend this is a 1. And I'm going to, just in my head, for good measure, I'm going to distribute this. Because if this was a 5 out here, it would certainly change the outcome. So I'm going to just quickly run through that. All right? So I think this is what it looks like, isn't it? 1 times x squared is x squared. Positive 1 times 2x is positive 2x. Now I'm going to move on to this. Negative 1 times negative 4x squared. A negative times a negative is a positive. So we have positive 4x squared. Negative times a positive is a negative. And negative 1 times x is negative x, isn't it? So I did my distribution here. I distributed these factors. And now I'm going to gather like terms. One of the most common mistakes made in algebra, and it makes people feel really dumb because they cannot figure out for the life of them what they're doing wrong, can only add variables that have the same exponential value. So if we can look at this together, this is x squared. Over here, these are 4x squareds. Look at this for a second, if you don't mind. This is 2x. This x is raised to the first power. This is negative x. It's also raised to the first power, isn't it? So we can see from the green and the yellow what we can and can't add together. So we have x squared plus 4x squareds. So one of them plus 4 more of them is 5x squareds. I know I'm not supposed to pluralize it, but I'm not an English teacher, so it doesn't matter. Einstein once said, why remember what's written down? So I just want to remember that I use these pieces, so I just check them off. So when I look back, I can realize I wrote it down, I used those pieces. 2x's minus an x is positive x, isn't it? And there's our solution. And there's our solution. Not too difficult. Remembering some important rules. 1, be careful. Look and see what you're being asked to do. Here, we were being asked to find the difference, to subtract. So we subtracted. How do we do that? We distributed this negative sign all the way through, and it changed the sign of everything we did, didn't it? After that, we went ahead and we gathered the like terms that we had. And we remember that the only time you can put variables together is if they have the same if they're the same variable to the same exponential value. That's the only way that we can add or subtract them. Okay? The rules for multiplying them are different, but we're talking about addition and subtraction today. Okay? Hey, excellent work. If you haven't subscribed, please subscribe, and your comments are always welcome. Thank you.